Okay, now let me talk about statistical model. There are two types of statistical model. First one is fixed effects model and next random effects model. So in this chapter we are going to talk about only fixed effects model. So the linear model, we write the model yij equal mu plus tau I plus epsilon ij. So yij is the jth observation of the ith treatment. Mu is the overall mean. Tau I is the ith treatment effect. Okay, treatment effect. So this is the random error component. This is the error component. So we assume error has normal distribution, actually they are independent, and 0 comma sigma square. This is the variance. So this, we can write this equation or we can modify this equation into yij equal mu I, that is the ith treatment plus epsilon ij. So now you see that comparing these two, we can write mu I equal mu plus tau I. So this, we need this one later. So you see the model. And other important thing is this. In the fixed effect model, summation of the treatment effects is 0. Summation of the treatment effect is 0. So I am not going to talk about SS treatment, SST, SSE, those equations, but those are given. Therefore, please read this whole thing because you have those equations. So I hope you can understand. Those are just equation, math type. So you can understand. But let me explain this, the F test in ANOVA. So what is the meaning of F test in ANOVA? In main, we are going to now do the hypothesis testing. Alright, so let me explain this. We know now what are we interested? We are interested in testing the equality of the A treatment means. In main, we have several treatments, 1, 2 up to A, 1, 2 up to A. So we are going to check mu1, mu2 up to mu A, are they equal or not. But we change little bit in our model. We change mu I equal mu plus tau I. So if we need to check the equality of the A treatment, then we, because of this relationship, we can check the random effects, treatment effect, tau 1 equal tau 2 equal tau A equals 0 and HA tau I not equal 0 for at least 1i. So this is the null and alternative hypothesis. Again, understand we can check this one because of this relationship. Right. Once we have a hypothesis in mean null and alternative hypothesis, now what is the next thing we need? Actually, we need test statistic. Yeah, you know we need confidence significance level, but it should be given. Therefore, next we need test statistic. What is the test statistic for this? It is f naught. F naught equal, you see that SS treatment, I will write down TRT treatment divided by degrees of freedom of that. What is that? A minus 1. Please read the section below this. Then you will understand. SSE divided by A time n minus 1. SS3 treatment divided by its degrees of freedom is MS treatment. Similarly, SSE divided by its degrees of freedom MSE. Okay, so then we know this has F distribution, degrees of freedom A minus 1 and A n minus 1. Now actually you should know how to check the F table. Please find the F table and check how to use the table. Alright, next you should know the equation. You know how to find the SST, how to find the SS treatment, and how do we find the SSE. So SSE error equal SST minus SS treatment, right? What is this meaning? So SS error is it is the within subject, and this is between treatments. If you read your note very carefully, you already know that. If you don't know, please go back and read the note because I mentioned it very clearly. Then we can use the Anova table for this. So Anova table. What is the Anova table? How do we use it? Yes, Anova table, it is given in the note. Please check the Anova table because you know treatments, error, total, degrees of freedom. Then we find the F naught equal MS treatment divided by MSE. So then actually we compare F naught with, you know, this has what? F distribution. This has F distribution and degrees of freedom A minus 1, A n minus 1. So we compare with the table values. Alright. So next is you should know how to draw the Anova table using R. You should know how R code. Again, you can draw the Anova table, or you have to find the each sum of squares, and you know you should know both ways. It means how to draw the Anova table in R in just one code, or how do we find actually both cases. How do we find SS treatment, SSE and SST, and how do we find the MS treatment and MSE, and then how do we find the F node. So how do we do this one by one, and How do we use this in the table? So you should know our code for this. That is your homework.